Greetings and welcome once again to my new calculus channel. My name is John Gabriel, and in this second part of three videos I'm going to be discussing the quotient as we realize it using the geometry of magnitudes. So if you haven't watched the previous video on addition and difference, or difference and sum, you should probably do that first, because I'm not going to cover everything that I covered in the previous video again in this one. So let's begin. Now, the quotient is simply the ratio of the antecedents where the same consequent is being used. So for example, here we can't just say that the ratio or the quotient of these two ratios is just the red line to this short blue line, because they do not have the same consequent. So first thing we got to do is we have to once again give them the same consequent, and we can do that by just doing that. Okay, so now they have this same consequent here, and we can just go ahead and say that the quotient or the division is a ratio of this line to this line, or just this line to this line, right? So if we had to treat these as, now what is the actual consequent in this case? What is it? It's approximately that much, isn't it? So if we said let's do about that, let's move that to about there, like so, and then we can see that this is approximately the correct value, because this here would then, if we assume this is a unit, then this would be 4/3 to 2/3, which means the quotient would be 2. In other words, this would fit this line here. This line here fit exactly into this line here twice, right? And the measure means, right? So here it's not showing an exact value because these are not exact. But we can fix that. If we had to say, let's do this. Let's make them both corresponding with a corner, and then you'll get 2. And then, as I said, it doesn't matter where you put the parallel lines. Okay, you'll still get the same answer. And that is simply what is the quotient. And of course, it's easy to see if you take the measure. Now, later on, once I'm done with the product, I'm going to show you that algebra, all you're doing is you're choosing a particular unit, and then you're giving names to the magnitude. So if you had to choose this as the unit, then this part here would be 1 unit, and then you would write the numbers as follows. You would write 2 as, for example, like that, 2 like that, okay, 2 like that, and of course it's in proportion to the unit ratio, which is like this, right? If we choose this distance here as the unit, and that's how we get measured. And of course, later on you'll see that in the mathematics that we do, we don't actually deal at all with the size of the unit. We don't include this part. So when we say 2, it's just 2, not 2/1 or 3/1 or whatever. Okay? So that's pretty much it. And once again, this is going to be backed up to Odyssey. I'll ask you to become a subscriber. If you're not ready, spread the news, donate dollars or credits on Odyssey. I could use any help you could spare. And I'll be joining you again soon for another video on the product, which, by the way, works is defined in terms of the quotient. So you'll see how beautifully the final arithmetic operation of all the basic operators tie in with what I've been telling you. So first we have difference and addition. difference being the most primitive. Then we have quotient, and then we have the product. And that's pretty much it. I'm John Gabriel. This is New Calculus Channel. Till next time, goodbye.